Shall we start? Yes, Tanmay, Kaustubh, Harsh.
Yes, sir.
Okay,
Yes, sir.
fine. Okay, only 50 has been joined. Okay, no problem. We'll start. Is it visible to everyone?
Yes, sir.
Okay. In earlier lecture, we had discussed about the special purpose walls. There are different types of special purpose walls: multi-purpose wall, multi-port walls, flush bottom walls, float walls, foot walls, line blind walls, night gate walls. And last parameter, the wall is wall inspection and test. And in earlier lecture, we have discussed about the multi-port walls. Now see the multi-port walls. There are different kind of ports. These are the L port, T ports. That kind of ports are used for flow patterns in multi-port walls. That kind of ports are used and can considered as a multi-port walls. In this multi-port walls, so we are consider different kind of applications of 3 walls, 4 walls, and the respective patterns of 4-way walls. And we are discuss the application of 4-way walls, that is a reversal of pump suction and delivery bypass of strainer or meters, and reversal of flow through the filter heat exchanger dryers. Now next wall, we'll see the flush bottom wall. These are the special type of walls which are used to drain out the piping, reactors, vessels. These are attached to the vessels on pad type nozzles. The disc in close position match with the bottom of the vessels or piping, leaving no room for hold up or stagnations. In flush bottom walls, there are 2 types of flush bottom walls. First one is a wall with the disc opening into the tank, and second one, wall with disc into the wall. In the first case, the stem pushes the disc into the tank to drain the liquid, and this type cannot be used when there are any internals which restrict the movement of the disc. The draining of the material, could be affected completely in the first case. In the second case, the disc gets pulled down into the walls, affecting the discharge of materials. There are 2 types of disc design available in flush bottom walls. First one is plug type, and the second one is ram type. Normally, the inlet size of a standard flush bottom wall is one size higher than that of the outlet size. There are special construction possible with both sizes. The outlet port is at an angle to the inlet port. Normally, 45 or 60-degree deviation is provided. The end connections are normally flanged. However, the smaller size sample or drain walls have been developed with welding end at inlet to withstand higher pressures. The maximum rating pressure is available for flanges walls as per regulatory code ANSI 300, and the parts of the flush bottom walls are identical to that of a globe wall, and the closing and opening actions are also similar. The shut-off is shown by disclosing against body seat. The disc could be globe type or ram type. Jacketed flush bottom walls are also possible if required for the services. The disc and seat also could be machined to such accuracy to serve the vacuum duty as well. Now, next type of wall is float wall. In float wall, to control the wall, it is used to control the wall of fluid in a revisors. Only inlet of the wall is connected with the supply pipelines and the outlet is open to revisor. There will be a float with lever which controls the movement of the piston regulating the flow. These walls are covered under Indian standard, that is IS 1703. There are two types. First one is a HP and second one is a LP. Depending upon the pressure holding capacity of the wall. First one is HP stands for the high pressure and second one is a low pressure. For we call the depending upon the pressure holding capacity of the walls. The body lever and internals are manufactured out of the gunmetals and float is of PVC or copper depending upon the temperature of the fluid. The lever length could be adjusted to suit the lever in the revisors. These walls have threaded ends and are connected to the wall of the revisors with hexagonal nuts. The visor need not be provided with nozzles. Only an opening is required. The level of liquid will always be below inlet connections. The maximum size of wall covered under the standard is 50 nominal bore, that is 50 NB, and special design has to be done if higher size wall is are required. These are called equilibrium float walls. Float walls are also called equilibrium float walls. Now next kind of wall is a foot walls. Foot walls are sort of non-written walls with strainers mounted at the open end of the pump section lines. These are used when the pump has negative section. The check action of the wall holds the priming fluid of the pump while the pumps are filled before starting. The suction strainer helps to hold the solids while the pump is sucking the fluid. So, priming the fluid we are studied in fluid of mechanics. So, these walls are covered under the Indian standards IS 4038. There are two types of check mechanisms available: the lip check and swing check. Here, two kinds of check mechanism is available in float wall. First one is lip check and second one is swing checks. The operation of this is similar to the non-written walls. Walls are available with either flange end connection or screw end connections. And the material of construction, the body is CI or gunmetal for the walls. Now next special purpose wall is a line blind walls. Line blind walls are used for positive shut off and replace a spectacle blind. Unlike blind plates, these are easier to operate and less expensive than a standard wall. The most common type of line blind wall is 3 bolt or 5 bolt line blind walls. Another design is the single gate line blind walls or pulp wall, which can be power operated or with hand wheels. There also exists a design of visible wedge line blind walls, which provides a full bore opening or positive blinding inside a seat in 3/4 enclosed body. No line residue can spill when wedges are being changed, and no line movement is necessary when spectacles are changed. Now, next wall, that is knife gate walls. In knife gate walls, the single seated walls used for slurry services. They are covered under MSSP standards. Being single seated wall, it can be only for unidirectional operations used for in pump industries. In its simplest form, the sliding wall consists of two stationary steel plates with large holes drilled through it. A third plate slides between stationary plates to perform wall operations. When open, this design offers no resistance to flow. The ability of the gate to slip through the plate effortlessly is the success of this design. The edge of this gate is set to sear the solids. An elastomer seal is used to keep the solid away from entering the space between the plates when opens to clean the sliding blade when retracts. Now, last subpoint under wall, that is wall inspection and test. Why it is needed? Wall inspection and test. If specified in the purchase order, the wall shall be inspected by the purchaser's inspecting authority at the place of manufacture before dispatch. If not, the manufacturer shall supply a certificate stating that the wall and wall parts comply in all respects with the relevant standards and regulatory codes, unless additional inspection is specified in the purchase order. The inspection by the purchaser shall be limited to this visual examination of any finished components at the assembly stage. Next, visual and dimensional check the finished wall. Third point, that is witnessing the required and specified optional pressure test. And regulatory codes referred for these tests are API 598 wall inspection and test. API 598 wall inspection and test. Now next is API 607 fire safe testing of soft seated walls. BS 6755 testing of walls. Now another test in wall inspection and test, that is a pressure test. And one more test is hydraulic test pressure. In pressure test, unless otherwise specified, shall be carried out on each wall, cell, hydrostatic, inclusive of body, bonnet, stepping box, and cover plates. For this test, disc, wedges, and plugs shall be in open position and ball in the half open position. Check valve shall have pressure applied to the upstream side. When walls with stepping box are tested, the back seat shall be tested for leakage with the wall in fully open position and stem packing removed or untightened. Now, next parameter is seat hydrostatics. For gate walls, the test is to be conducted for each side of the disc. For globe walls, pressure is to be applied under the disc. For check walls, it is also on the downstream sides. For ball walls and plug walls, it is to each side of ball and plugs. Now, next parameter is seat pneumatics. Earlier, we had considered seat hydrostatic. Now, see the seat pneumatics. All gates, globe, plug, and ball walls are air seat tested at minimum of 80 to 100 psig with liquid on the side, which is not under pressure. This test is not required for check walls. It's required only for gate wall, globe wall, plug, and ball walls are air seat tested. Services low for walls used for vacuum services. A low pressure test the sheet shall be carried out. Now next is hydrostatic test pressures. In hydrostatic test pressures, the hydrostatic seat test pressure of soft seated walls shall not exceed the body rating or whichever is lesser, or we have to refer a regulatory code for the walls. For hydrostatic tests, the test fluid shall be water at ambient temperature unless the use of another liquid is agreed. The use of high chloride containing water should be avoided. The water may contain water soluble oil or rust inhibitors. Fire test is a destructive test and carried out only in exceptional cases when specified. The arrangement and test shall be as per API 607 or BS 6755. So here we are discuss about the wall inspection and test. Pressure test, under pressure test, we have discussed the cell that is considering the hydrostatics inclusive of body, bonnet, stepping box, and cover plates. Now, next parameter is body seat hydrostatics, and third one is a seat pneumatics, and next test is a hydrostatic test pressures. So, sir, all discuss related to walls. Now here our wall topic is completed. We are consider different kind of test, isolate tests, regulating tests, or we call the control flow tests, or needle walls, that kind of swing check walls, and the different types of walls seen their line diagram as well as 3D diagrams, and somewhere we have seen the animation, the working of walls. So this is all about the walls. If you have any questions, any doubts in wall, so we can discuss the all walls, whatever we are discuss from first lectures. Anyone, any doubt, any questions? Yes.
No, sir, no doubt.
Yes, Aditya, Varun, Tanmay, Kaustubh,
No doubt,
Athar.
no doubt, sir.
No doubt, sir.
Okay, fine.
No doubt, no doubt, no doubt.
Okay, now we'll start. Next topic, I will upload assignment first two topics, standards and codes and walls, today or tomorrow. And now we'll start the next topic, that is piping drawing. So might be you heard the name of drawing in engineering in first years, and you've seen the orthographic projections, isometric projections, pictorial views, plans, isometric presentation of piping systems. Whatever we have studied in first year engineering drawing or engineering graphics. Now again, we'll discuss the piping drawing considering the orthographic and pictorial views, that is called isometrics, and ways the drawings are always considered as the language of engineers. The language of engineers. The machine drawing and the geometrical drawings are taught in the basic engineering curriculums. Piping engineers derive basics from these to represent the pipeline routing on the drawings. There are two types of views used in piping drawings. First one is orthographic. In orthographics, plan and elevation. Again, no need to define what is a plan and elevation, but we are already studied in engineering graphics or in engineering drawings. Now, next one is a pictorial. We call the isometric views. In piping layout is developed in both plan view and elevation view, and section are called details are added for clarity wherever necessary. These drawings are called the general arrangement type piping. In short, we call GA arrangement of piping. To represent a three-plane piping in two dimensions of the paper, certain symbols are followed. Most commonly used symbols are given in tables. So I will show you all tables. So here, basic symbols. Is it visible to everyone? Piping symbols.
Yes.
Most commonly used symbols or orthographic symbols are available in this tabular form, and they are used for speeding up the manual drafting, and also symbols library for computer draftings. Whenever we use the PDS, PMS, that kind of softwares in their library, all symbols are available. So we can, like AutoCAD, we can draw the all symbols and we can represent the piping drawings. In complex system, especially within unit or plan building where orthographic views do not illustrate the details of design, pictorial views in isometric presentation is drawn for clarity. Especially printed isometric sheets are available with line drawn vertically and 30-degree clockwise and 30-degree counterclockwise respectively from the horizontal axis of the paper, by the use of which 3D representation of the pipeline can be prepared. Elbows. Okay, sorry. Now here we can use the clockwise and anti-clockwise directions at 30 degrees from the horizontal axis. The paper by which 3D representation of the pipelines can be prepared. So the plan and isometric presentation of a piping system. The purpose of drawing is to give detailed information so that the pipelines could be fabricated and erected to satisfy the process requirement in chemical industries, petrochemical industries, or process industries, or pharmaceutical industries. Prior to making the piping drawing, the equipment layout drawings and plot plan are prepared, and these drawings are used as the basis of developing the piping drawings. Sometimes preliminary piping study is made to fix the equipment coordinates. The other data required for the development of piping drawing are defined in the paper on equipment and piping layouts. For presentation of unit piping layout, the scale adopted usually are 1 is to 25 or 1 is to 33 and 1 is to 100 for the pipe racks. What we are considered different kinds of scale in engineering drawing or engineering graphics. There are two types of scales. One is a reduced scale, another is a enlarged scale. So we can reduce the object size and we can enlarge the object size with the help of scales. So that kind of scales are adopted in piping layouts. So there are different sizes of drawing sheets available for the preparation of the drawings. Later we'll see the different sheets available. And the Indian standards IS 10711 standardize the drawing sheets. Might be you heard the standard sizes in the drawings. First one is a A0 size, A1, A2, A3, A4, and overall dimension in millimeters. Do we know size and overall dimensions? What we are studied in engineering, graphics, or mechanics, in drawing or graphics, and we define different kind of sizes and overall dimension. That is A0, A1, A2, A3, A4, and we are consider overall dimension in millimeters. For A0, we'll consider 841 by 1189, and A1 for 594 into 841. That kind of overlay dimensions are used for A1. Like similarly for A2, that is 420 into 594. And third one is size A3, and here overall dimension is 297 by 420. And last size is A4 size. In A4 size, 210 by 229 overall dimensions. I hope if you remember this overall dimension and size, what we have studied in engineering, drawing, or graphics. So here you see the different kind of symbols are used in piping industries, and based on that we can draw the different arrangements in the piping engineerings. The piping general arrangements say is normally drawn on A0 size sheet, and if the area is to be covered in small size, then A1 size sheet is also used. Piping group produces a key plan, the plot plan on a small scale, that is 1 is to 500 or 1 is to 750 or 1 is to 1000, which can be accommodated on a A0 size drawing sheet as per scale, and dividing the area of the site into smaller areas identified by key letters or numbers. This is added to the piping drawings for reference purpose. The subject area of particular drawing is hatched or shaded. Might be you hatch or shaded in your machine drawings. Here somewhere you drawn the detail and assemblies. When you cut the portion, then we can hatch or shade the particular portion. Might be studied in development of surfaces in engineering graphics or engineering drawings. The dimensional details of the title blocks are specified under the Indian standards IS 11665. Might be you drawn the dimensional details of the title blocks at the bottom on the right hand side, and you are written name, seat numbers, your roll numbers, and you use the different kind of symbols, first angle symbol, third angle symbols, whatever symbols are available or methods available in engineering drawings or graphics. So likewise, we can consider the dimensional details of the title blocks are specified under the Indian standards IS 11665. The drawing sheet is divided along the length and breadth in equal space. The the longitudinal blocks are identified by alphabets and those along the breadth numerically. These coordinates are used to locate the area on the drawings. The direction of the north is taken either towards right or left. Here you can see the direction in typical layout. Here you can see the typical layout of development of piping general arrangement drawing. So here we use the north directions. So taken either towards the right or left. See, in next isometric drawing of piping engineering, the here we can mark the different components and different equipments are used in piping industries. So here the direction of the north is taken either towards right or left on the top of the drawing sheet. The This direction is kept constant in all the areas covered in the plant in actual industry. So, so is the scale of the drawing. Then, how to start the piping GA? First, we'll see the all symbols in piping upward bendings. See, if pipe is going in upward direction, then there is different kind of bendings. BW bendings, SW bendings, and screw elbow bendings. Butt weld bending, socket weld elbows. These are the different kinds of elbow along with their weld connections. So here we can see the different plan end views 1 and end view 2. See the butt weld elbow or socket weld elbow, screw elbow, and flange elbow. These are the abbreviations so we can mark the particular elbows in plan. So we can see the what is the plan? Anyone? Yes. In engineering drawing or engineering graphics, we have studied the plan and elevation and views. That is, it may be side view, it may be left hand side, LHS or RHS. That kind of views we have studied.
So the view from above.
Correct, correct. That is called as a plan. And here, end view, so we can see from the left hand side or right hand side, and we can mark the end view 1 and the end view 2 based on actual representation of piping components. So here there is a termination line. So this line we call the termination line. Is it clear to everyone? Here, is it visible? This line we call the
Yes.
termination of pipes. And here we place the symbol of socket welds, and another is pipe going downward direction, and we apply butt weld elbow. So that kind of bendings are used in downward bendings. Now next is upward bending. So again we'll use the same kind of connections ends for the elbows, and see the upward bendings. Some pipes are going in upward direction. In earlier slide, pipes are going in downward direction. So here you can see their plan end view 1 and end view 2. Based on that, we can draw the different plan layouts in piping drawings. Now next is change of direction at 90 degrees. For flange connection elbows. And here, in change of direction at 90 degrees, there is upward bendings. In upward bendings, we can use flange and elbows. And see the three views. First is the plan, second is the end view 1 and end view 2. Similarly, change of direction at other angles, it may be 30 degrees, 40 degrees, 60 degrees, any angles. You can see the downward directions, upward directions, and 180-degree return. So that kind of direction you can see in piping drawings. So here you can visualize the plan end view 1 and end view 2. So that kind of symbols are essential in piping engineering. Now next is a branching. We need to connect the third pipe. If there is a pipeline, so we need to fix the another pipes. So that kind of branching that we are discussing in earlier lecture, that is a branching. So here we can modify the original lines with the help of branching. So for this purpose we can use the T's in downward directions. First is a butt weld T and second one is socket weld T. So that kind of T's are used with their different views. First is a plan, second one is a end view 1, and third one is end view 2. So that kind of symbols are used in piping industry. Now next is downward. Screw T's, flange T, stub connections and half coupling. So that kind of symbolic representations are used to mark the plan end view 1, end view 2. So use that kind of plans and to draw the drawings in piping industries. Then how to start the piping general arrangements. Obtain the drawing numbers and fill in the title blocks. So here at the bottom there is a title block. Okay, with drawing numbers and title at the bottom right hand corner of the sheet. Might be you have drawn that kind of title in machine drawings and written bill of materials and remaining informations. This is the first point. Now next point is place the north arrow at the top. In earlier here this sheet in isometric piping. So here place the north arrow at the top left or right hand corners of the sheet to indicate plant north. Do not plant drawing in the area above the title block of drawings, as this is allotted for general notes, numbers and title of references drawings, and brief description of changes during revisions, and the bill of materials wherever applicable. So that are the points so we can cover in piping general arrangements. Now next is process equipment and piping have priority to the piping general arrangements, that is piping GA. The piping drawings are started after fixing position of the equipments like distillation columns. Here in isometrics you'll see the distillation columns, different kinds of walls. First we have to fix position of the equipments. Now next point is equipment layout is a reproduce on the piping GA to its scale and drawn on the reverse side in case of manual draftings. In case of CAD, separate layer is used. The major primary beams and secondary beams are also shown if area covered is indoor. Now next one is background details which governs the piping routines such as floor, drains, havoc, ducting, electricals and instrument cable trays, etc. are also drawn in faint on the reverse side of the drawings. For this purpose, we can use different kind of pencils. So here we can use the H1 that we can mark on the reverse side the drawing sheets. And next section is utility sections are also established so that the most convenient utility header routing can be carried out. So this is all about how to start the piping GA. Do you have any questions, any doubts? You can ask your doubts and questions. Yes, anyone?
No, sir, no
Yes.
doubts.
Okay, fine. Then We'll close this session here and we'll continue in next session.
Thank you, sir.
Okay, fine.
Thank you, sir.